In the realm of machine learning and data science, configuring job run settings for a script is a crucial step in preparing a model for deployment. This process ensures that your script runs efficiently and effectively in a production environment. Job run settings encompass various parameters and configurations that dictate how and when your script executes, including resource allocation, scheduling, and error handling. Understanding and properly configuring these settings can significantly impact the performance and reliability of your deployed model. Job run settings are vital because they directly influence the operational efficiency of your machine learning model. Proper configuration can lead to optimized resource usage, reduced costs, and improved model performance. Conversely, poor configuration can result in resource wastage, increased costs, and potential failures. By meticulously setting up job run parameters, you ensure that your model runs smoothly, scales appropriately, and handles errors gracefully, thereby providing a robust and reliable service to end users. Resource allocation is a fundamental aspect of job run settings. It involves specifying the computational resources required for your script, such as CPU, memory, and GPU. Proper resource allocation ensures that your script has enough power to execute efficiently without over-provisioning, which can be costly. For instance, a script that processes large data sets may require more memory and CPU power, while a script that involves deep learning might benefit from GPU acceleration. Balancing these resources is key to optimizing performance and cost. Scheduling is another critical component of job run settings. It allows you to automate the execution of your script at specified times or intervals. This is particularly useful for tasks that need to run regularly, such as data ingestion, model training, or batch predictions. By setting up a schedule, you can ensure that your script runs consistently without manual intervention. Additionally, scheduling can help in managing computational loads by running resource-intensive tasks during off-peak hours, thereby optimizing resource usage and reducing costs. Error handling is an essential part of configuring job run settings. It involves defining how your script should respond to various errors or failures that may occur during execution. This can include setting up retries, logging errors, and sending notifications. For example, you might configure your script to retry a failed task up to 3 times before sending an alert to the operations team. Effective error handling ensures that transient issues do not disrupt the overall workflow and that critical failures are promptly addressed, maintaining the reliability of your deployment. Environment variables play a crucial role in job run settings by allowing you to configure your script's runtime environment dynamically. These variables can store configuration settings, such as database connection strings, API keys, or model parameters, which can be accessed by your script during execution. Using environment variables helps in maintaining flexibility and security, as sensitive information can be managed outside the script's codebase. This approach also facilitates easier updates and modifications to the configuration without altering the script itself. Managing dependencies is a key aspect of configuring job run settings. Dependencies include libraries, frameworks, and other software components that your script requires to run. Proper dependency management ensures that all necessary components are available and compatible with your script. This can be achieved by using package managers, such as pip for Python, to install and manage dependencies. Additionally, specifying exact versions of dependencies can help in avoiding compatibility issues and ensuring consistent execution across different environments. Logging and monitoring are critical for maintaining the health and performance of your deployed model. By configuring logging, you can capture detailed information about your script's execution, including errors, warnings, and performance metrics. Monitoring tools can then analyze these logs to provide insights into the script's behavior and identify potential issues. Effective logging and monitoring enable proactive maintenance, allowing you to address problems before they impact the end users. This ensures that your model remains reliable and performs optimally over time. Security is a paramount concern when configuring job run settings. This involves ensuring that your script and its execution environment are secure from unauthorized access and vulnerabilities. Key security practices include using secure connections, encrypting sensitive data, and implementing access controls. Additionally, regularly updating dependencies and applying security patches can help in mitigating risks. By prioritizing security in your job run settings, you protect your data, model, and infrastructure from potential threats, ensuring a safe and trustworthy deployment. Scalability is a crucial factor in job run settings, especially for models that need to handle varying loads. Configuring your script to scale efficiently involves setting up auto-scaling policies that adjust computational resources based on demand. This ensures that your model can handle peak loads without over-provisioning during low-demand periods. Performance tuning, such as optimizing code and resource usage, also plays a significant role in scalability. By focusing on scalability and performance, you ensure that your model can grow and adapt to changing requirements seamlessly. Before deploying your script, thorough testing and validation are essential to ensure that it performs as expected. This involves running your script in a staging environment that mimics the production setup and verifying its behavior under various conditions. Testing helps in identifying and fixing issues related to resource allocation, scheduling, error handling, and other job run settings. Validation ensures that your script meets the desired performance and reliability standards. By rigorously testing and validating your script, you minimize the risk of failures and ensure a smooth deployment. To illustrate the importance of configuring job run settings, let's consider a real-world case study. A financial services company deployed a machine learning model to detect fraudulent transactions. By meticulously configuring job run settings, they ensured optimal resource allocation, automated regular data updates, and implemented robust error handling. This resulted in a highly efficient and reliable fraud detection system that could scale with increasing transaction volumes. The company's proactive approach to job run settings not only improved model performance, but also enhanced customer trust and satisfaction. To effectively configure job run settings, consider the following best practices. 1. Start with a clear understanding of your script's requirements and resource needs. 2. Use environment variables for flexible and secure configuration management. 3. Implement robust error handling and logging to maintain reliability. 4. Regularly update and manage dependencies to avoid compatibility issues. 5. Prioritize security by encrypting sensitive data and applying access controls. 6. Test and validate your script thoroughly before deployment. By following these best practices, you can ensure that your job run settings are optimized for performance, reliability, and security. Configuring job run settings is a critical step in preparing a model for deployment. It involves various aspects, including resource allocation, scheduling, error handling, and security. By meticulously setting up these parameters, you ensure that your script runs efficiently, scales appropriately, and handles errors gracefully. As you move forward, apply the best practices and tips discussed to optimize your job run settings. Continuously monitor and refine these settings to adapt to changing requirements and maintain the performance and reliability of your deployed model. With a well-configured setup, you can achieve a successful and robust deployment.